Hi, welcome to this video on configuring Cisco ASA multi-context mode. This video is part of my CCIE Security Labs with Kelvin videos, which are available on my YouTube channel, Network Wizkids, for those that are not watching this on YouTube. Starting off with some of the main points in relation to the Cisco ASA running in multi-context. Essentially what this is a single firewall that allows you to carve up that firewall into multiple ASAs, multiple virtual ASAs if you like. So for those that are familiar with the concept of VRFs, this is essentially the same thing but for the Cisco ASA. In multi-context mode, you can share ASA physical interfaces, but only in rooted mode. For transparent mode, you do need to have separate interfaces as well, which is covered in the next point there. So unique physical interfaces are required when the ASA is deployed in transparent mode. We'll take a look at the rooted mode where shared interfaces are used in the lab demonstration a little bit later on. Layer 3 interfaces can be shared between contexts, but they must have different MAC addresses. There is also something called resource management, and this allows you to allocate a set amount of resources to each context. So say for instance you have an ASA running multi-context and you have 3 customers, each with their own context. But one customer pays for more resources or needs more resources. You can actually allocate more resources to that context and less resources to the other 2 contexts. By default, all ASAs, excluding the 5506, is licensed for use of up to 2 security contexts. So when we break down the context, when you actually first start off with a multi-mode or multi-context Cisco ASA, the contexts are broken down as the following. So you've got the system context. So this is the start. This contains the startup configuration and gives you the ability to create and list all of the contexts that are configured. You have the admin context. So this is the context that gives you the ability to access the Cisco ASA and all the other contexts within configured on that ASA. And then you've got the individual contexts. So these are the contexts that you create. So the let's say for instance customer 1, customer 2 and customer 3 contexts. So these are the individual contexts that you can create. There is some limitations when it comes to the Cisco ASA multi-context, and these are that only dynamic routing protocols such as OSPF v2 and EIGRP are supported. There isn't any support for RIP or OSPF version 3. There's no support for multicast, however multicast routing, as we've just spoke about, is the exception. There's no support for threat detection. There's no support for unified communications, and there's also no support for QoS. And I've put there in bold at the bottom there, so depending on the version that you're using, these limitations may differ, so it's always worth checking the Cisco documentation for the version of code that you are using. So just taking a look at the multi-context in more detail. So the multi-context mode needs to classify packets. So there's something called packet classification. So how does the ASA know where to send packets if you are using certain interface or interface type? So in this example we've got an example whereby we've got one context that's using gig 01 and then we've got another context that's using gig 02. So in this case the multi-context ASA is using unique interfaces, so there's no shared interfaces there. So what happens then if we have an ASA in multi-context that is sharing an interface with different contexts? How do we classify packets? So this is actually a recommended way on how to classify packets. So we do this by using unique MAC addresses for each context on the interfaces, and we'll take a look at this a little bit later on in the lab. And this is, as I say, the recommended way to use unique MAC addresses in order to classify packets, so that packets know where to be sent based on the MAC address. Now, what happens if you don't use unique MAC addresses or configure unique MAC addresses? Well, the next way of classifying packets is to use network address translation. However, as I've put there, it's not recommended, as not all traffic may be translated. So let's say, for instance, you have a ASA firewall and you've got one subnet that's being translated, but then you've got another subnet that's not being translated, but it's still passing through that multi-context ASA. You may run into issues. So this is not a recommended method, however, it is an option if required. So in our example, we can see that the source address is 209.209.209.5. Destination is 208.208.1, which is gig 02 outside, and then we've got the rail addresses 192.168.10.10, which is actually going to fall under context 2. But as you can see, gig 01 is sharing the interface between context 1 and context 2. So what would happen here is it'd use a network address translation to translate to the second context address. So again, the recommended way to configure or to classify packets is to use the unique MAC addresses, or you can use the individual interfaces. But if you have multiple interfaces being assigned to different contexts, you're quickly going to lose interfaces. So it's always best, as I said, to use unique MAC addresses and share the interfaces where necessary. So to configure ASA in multi-context mode, it's pretty straightforward. So you first need to configure the mode. So when you do that, a reload will occur. You then need to, well, optionally, actually, you can configure resource classes. These are what I spoke about at the start of the presentation, whereby you can assign more resources to a particular context over another context. Again, that's optional, so you don't need to do that. After you've done that, you then create a context and config URL. This is where the configuration should be saved for that context, and you then also allocate interfaces to that context. If you're using shared interfaces, use auto generation of MAC addresses for those interfaces, and we'll take a look at that in the lab and how to do that. If you don't want to use auto generation, you can manually specify MAC addresses to be used. Once you've done that, assign a resource class to each context. Again, this is optional, so you don't have to do this, and will probably only be done if you have carried out step number 2. Once you've done that, change to the context and configure the actual interfaces, so the IP address, the name, security level, etc. And then last of all, verify the configuration in the system context as well. So we have got a lab today that we're going to take a look at, and we'll just switch to that now. So here's the lab, pretty straightforward setup. So we've got one ASA whereby we're going to be configuring in multi-context mode right here. and then we've got what we call an outside PC, and then we've got context 1 PC and context 2 PC. So if you've not already guessed, these devices obviously have different subnets and will be assigned to different contexts on the ASA. However, you can see that we're using the same shared interface for both of them. So we will need to assign or auto-generate MAC addresses. So we'll start off with the configuration now. And this is a clean ASA, so there's no configured. So if we just do show mode, we can see that the mode currently in play is single. So we need to change that mode now. And we do that by mode and then multiple. And as you can see here, this will change the behavior of the device. We get a warning, and also, as I mentioned in the presentation, this will force a reboot of the device. So if you're happy with that, confirm and go ahead and convert the system configuration. Make sure that if you are doing this on a live environment, you obviously back up any configurations that was on the device previously, just in case you need to revert back. So we'll just let this device reboot. So now that the ASA is now rebooted, we'll just go ahead and do a show mode. And what we can see now is that the context is running multiple mode. So we've actually got multi-context mode now. So we should be able to do show context. And what we can see is we're currently at the admin context at the moment. So what we're going to do is we're not going to configure resource classes for this demonstration. We'll go straight into creating a context and proceeding from there as per the topology. So to do that, let's say we wanted to create context, and we'll call this context 1 for the purpose of this demonstration. And now we can see that the context 1 has been created. So now we can add a config URL, and I'm going to save this to disk0, and I'm going to call this context1.cfg. Okay, so now if I just do a show context, we can see there that we have context 1 that's being created. We can see that the resource classes being used are default, and we can also see that no interface is assigned at the moment to either admin context or context 1 that we've just created. Our config URL is here, and that's where we'll be saving our config. So what we need to do now is we need to allocate interfaces. So in our particular example, we need to allocate Ethernet 0 and 1. So let's just do show interface. Yep, so we'll do allocate interface ETH0. So once we specified ETH0, that should now allocate that, and also ETH1. So if you try to do something like ETH10, you can see there that that interface doesn't exist, so it'll give you invalid interface right there, so you can't do that. So again, if we do show context now, we should see those interfaces. So you can see those interfaces now assigned to context 1. So now that we've done that, we will also do, while we're in the system context, we will create context 2. Okay, so now that's been created, and again we'll do config -URL, and we'll call this one disk0 context 2 .cfg. We'll just issue a show context there. Yeah, that's fine. Okay, so now let's allocate the interfaces. So again, because we're sharing the interfaces, we're going to allocate if0 and 1 as well to that. So now if we just do a show context, we can see that context 1 and context 2 has the same allocated interfaces. So we're not going to do the random MAC auto generation just yet. What I want to do is I want to show you that the MAC addresses for those interfaces will be the same, and that's where you'll have the issues if you're not using network address translation or you're not using individual interfaces or the auto generation of MAC addresses. And then we'll come back and we'll do the auto generation of MAC addresses and we'll take a look again. So to change to a context, all we have to do is do change to context, and context 1 in our case will change to, and there we're in that context now. So if we just do show context, we can see that we're in this context, context 1. Now if we just do a show name if, you can see nothing's configured, no IP addresses or anything. And let's just do a show interface if0 for instance. We need to bring that up actually before we can see the MAC address. So I'll tell you what we'll do. We'll issue a security level. So in fact, let's give it a name. So interface if0. We'll give it a name of inside, leave the security level for 100, and we'll give it an IP address of 192.168.20.1/24, and then we'll issue a no shutdown. And now we should be able to see, not that command, there we go. So we should be able to see now the configuration and the MAC address. So you can see the MAC address here. So let's just exit out of this before we configure if1, and we'll go to change to context 2, and what we'll do is we'll do the same for if1, and we'll look at the MAC address for that as well, just to show you that they'll end up with the same MAC address unless you change that manually or use the auto generation. So we'll do if0, and we'll do name if inside, leave the security level, and the IP address for this is 192.168.30.1. Issue a no shutdown for that. And now let's do show interface if0. Now if we look at the MAC address, it's exactly the same as the MAC address on context 1. So we would have problems classifying where a packet should be sent to when we're using shared interfaces. So to get around that, what we do is change to system, get to the system context, and as you can see all the context again when you're in system. And what we need to do is we need to do the MAC address auto generation. So if we just do MAC address auto, so you can see there that on it auto generate MAC addresses for context interface. So if we now go ahead and enter that, I should have entered a prefix actually, so let's just say 19, prefix 19 or 192 even, let's just leave it at that. Now we change to context 1, show interface if0, and you can already see that the MAC address has changed. And again, we'll change to context 2, and we'll do the same command. And again, you can see that the MAC address is different now. So we can see at the end we've got 0006, and then on context 1 we have 0008. So now our packet shouldn't have any problems being classified. So that's good. So what we'll do while we're in context 2 is we'll configure if 1, and we're going to give this a name of outside, leave the security level, and IP address will be 192.168.10.1. okay, /29, so it's actually 248. I'll shut down, exit. We'll do the same for context 1. Okay, so we'll go interface if 1, name if outside, IP address. And because we're using the same shared interface, this will use 192.168.10.2 248. Now shut down, exit. So now if we just do a show run, we can see that we've got the context configured in system. We can see the allocated interfaces for both contexts right there. So we're all good on that front, and the interfaces are up. So if we change back to context 1, and we'll just do a show name if, we now see that we've got 2 interfaces there. So IP address, we've got our IP addresses assigned, and then if we change to context 2, we issue the same. We've got the same interface names and different IP addresses on the inside, and IP address on the outside actually, just by the octet. So what we'll do now is we'll configure the context PCs, and we'll test some connectivity. 20.10 we'll give it, and 20.1 is the gateway for context 1. Context 2, we'll give it .10. and 30.1 for that one. And while we're here, we'll just configure the outside PC 192.168.10.8, and that's a /30 10. So in fact that's a so it should be 9, and then we'll do, in fact 9 will be root 5 even, so we'll do 10.10, and that should be 9. There we go. So let's take a look at root 5, which has no configurations on clearly, so we'll just configure that one as well so that we've got full connectivity across the topology. Okay, so I'll just quickly configure this and then we'll return back to our multi-context configuration. 192.168.10.9 /30. I'll shut down. If 0 192.168.10.3, this will have to be 248. I'll shut down. Let's just do a ping from here to the outside PC first, 10.10. Okay, so that's good. Let's do a ping to 192.168.10.1, which is context 1 IP, outside IP, so that's successful, and then context 2 outside IP, which again that's successful as well. So just save that configuration, and now we've got a full topology, or full working topology. So what we'll do is we'll go back over to the ASA, and we're in context 2 at the minute, so let's just do a show route. So we can see, it's got a separate routing table, so we can only see the route for 30.0, which is connected, and the outside, which is 10.0. So you can't see anything in relation to 20.0, which is good. And if you change to context 1, we should have the same as well. Okay, so you can't see the 30 subnet there either. Cool. So now if we go back to our context PCs, now that they're configured, let's just start by pinging the gateway. So 192.168.20.1. This is for context 1. And that looks like it's not reachable, and that's because this switch hasn't come up fully yet. So we'll just get started with that. Let those interfaces come up, and then we'll try connect again. There we go. So these interfaces should change now. And we'll just change the host name of this while we're here. Okay, so now it should be good to test again. Okay, so now we can ping the context 1 gateway, which is good. And if we try in context 2, one 192.168.30.1, we can also ping the gateway there. So what happens when we try to ping the outside PC? So let's try first from context 1, 192.168.10.10. You can see that's timing out, and I also know the reason why. We need to first enable ICMP inspection, which we don't have on at the minute. So let's quickly enable that in the default inspection class. So we'll do inspect ICMP, and let's give it a go again. Context 1. And that's timing out again. So what we need to do is we need to actually specify the route. So let me just do a show route. So let's do a route, and this is for context 1 at the minute. So let's do a route outside. Anything going to 192.168.10.8/30 goes 192.168.10.3. And then likewise on the route of 5, let's just do an IP route, and we'll just route. We'll put a default route in going to. In fact, no, we won't. Let's do a 192.168.20.1 10.0, and this is going to go via 10.1, and then if we change this for anything going to 30.0, this will go via 10.2. Okay, so now this should work now. So now if we go back to that VPC and context 1, still not working. So let's just take a look at the interfaces. That one is up. They're both up. Let's have a look at the routes. So we can see our static route there goes via 10.3. And while I'm here, let me just see if I can ping from the ASA context. 10.10. Okay, so that's fine. So what I'm going to do is I'm just going to enable login. Buffer, then we'll do debugging. Okay, so login's enabled, and let's just try to ping that machine again. So we can see that the outbound connection is being built. So let's just take a look at the IP addresses again. So show IP address and 10.2 is the outside, and that should be 10.1. So let's change that. If one IP address 192.168.10.1 248. So I think what I've done, so let's just change to, in fact, let's do not IP address, change to context 2, show IP address. Yeah, so I've got the IP addresses the wrong way around for each context. So what I'll do, interface if one, IP address 192.168.10.2, that one should be 248, and then change to context 1. Let's change this to 10.1. Okay, so that's better. So I think we're gonna have to add the route again. Yeah, so let's do route outside. Anything going to 192.168.10.8. Go via 192.168.10.3. Okay, so that should be fine now. So now let's try and ping the outside PC. Okay, now we see that that works. So that's brilliant. So now we've got that connectivity through context 1, from context 1 PC going to outside PC. So now if we just go back to that ASA and we change to context 2, and we should have the correct IP address. Yep, 10.2 now. But if we look at the route, you can see we haven't got the static route that points to the outside PC subnet. So technically, although we're sharing the interface, we still have a separate routing table, and context 2 PC should still not be able to get to outside PC. So let's try ping 192.168.10.10. So as you can see, although context 1 can get there because it's got a separate routing table, context 2 cannot get there. So now if we add that in, so if we just do root outside 192.168.10.8 goes via 192.168.10.3. We now should be able to get to that outside PC from context 2. So let's just do a show root, because that didn't seem to work. So 10.3. We can see that the subnet that I've entered should be that's right. So 10.3 goes via, so that's fine. So let's just do a short IP address 30.1. So let's do ping 192.168.30.10. So we can get to the PC. Let's just do a short IP route. So it goes via 10.2. So that should be fine. The interface is up. And says ETH0, so they should be fine. So let's just try again from context 2. Okay, so that's timing out. So let's see if we can reach the gateway 30.1. So that's fine. Can reach the gateway. Let's try 10.3. So we can't reach 10.3. And I think I know why, actually, because we didn't enable ICMP inspection on context 2. So although we've got the routes in place and everything's fine this time around, we need to still enable ICMP inspection. So let's enable that, and then we should be able to ping from context 2 now to the outside. There we go, so that's working anyway. And 10.10, there we go, so that's fine as well. So as you can see, there's a few things to take into consideration, but the main point demonstrated there was the auto generation of the MAC addresses to classify the packets, the context creation themselves, and when using same or shared interfaces, how you need to obviously have separate configurations for each of those contexts, especially because we have separate routing tables as I showed you in this demonstration. So now if we just go back to our system context, change to system, and we just do a show context detail. So what you can see here is it just shows you the interfaces that are mapped to it in more detail, config URL, the context name, etc. as well. If you just do a show run, you can see that you've got MAC address auto prefix or MAC address auto generation. I've specified prefix 192 for that, and we can see the interfaces that are available on this device. Obviously 2 and 3 are shut down because they're not in use. Also see the default resource class that we spoke about, which we've not demonstrated in the demonstration today. So each of the contexts will be assigned this default resource class. So we can see the limits that are specified here for SSH, ASDM, Telnet, MAC addresses, etc, etc. So again, like I say, you can create your own resource classes and assign them to individual contexts as you wish. But that's pretty much it for the demonstration on multi-context. We verify the configuration in the system context as the last step. I've got some useful links here, so got some useful links on the multi-context for 9.0 and 9.6, as well as links to my social media and my other platforms. Please feel free to drop me any questions in the comment section below if you do have any. If you've enjoyed this video, please make sure you support by clicking like and subscribe. And you can also hit the notifications bell so that every new video that I upload, you will receive a notification so that you don't miss out on the latest content that I publish. But until next time, thank you for watching.